We've been studying ionic bonding for a while now. The goal of this PowerPoint is to bring together all of the concepts that we've been studying and hopefully to help you to understand them a little bit better. There are different types of bonds which can be active between groups of atoms. In this chapter, we focused on ionic bonds, which involves the transfer of electrons to make ions. Next chapter, we're going to focus on covalent bonds, which doesn't involve a transfer of electrons, but instead a sharing of electrons. We're also going to talk a little bit later in this unit about metallic bonding. The goal of bonding is stability. There's no better example of stability in the periodic table than the noble gases. Every atom is trying to achieve an electron configuration similar to the noble gases. And so that's the basis for the octet rule. So this is an example of the bonding of sodium chloride. In the case of sodium, you have one valence electron, and if it loses one valence electron, it'll look like neon. In the case of chlorine, it has 7 valence electrons, and if it gains one electron, it will look like argon. So sodium and chlorine fit nicely together. The sodium atom will give one electron to the chlorine atom, and everybody will be happy. After losing one electron, you can see sodium has 8 electrons in its outer shell. And after gaining one electron, you can see that chlorine also has 8 electrons in its outer shell. Thus, the octet rule. There are 2 things that are important to learn from this slide. The first is that the sodium and chloride ions stay together because of their opposite attractions. The second is that the overall charge for the compound is 0. Sodium having a +1 charge balances out the chlorine having a -1 charge. That will always be the case when forming ionic compounds. When you name an ionic compound, the name of the cation stays the same. So in the case of magnesium chloride, magnesium stays magnesium. But the anion's name changes, and you always add IDE to the ending. So the result is magnesium chloride. Ionic compounds are very strong. The strength of an ionic compound comes from the crystal lattice structure. In this structure, the green spheres represent the chlorine atoms and the purple spheres represent the sodium atoms. If you look very carefully, you'll notice that every chlorine atom is surrounded by 6 sodium atoms and every sodium atom is surrounded by 6 chlorine atoms.